In this project, we'll control the color of the entire LED strip using a variable. Anytime we're using the LED strip, we want to include the ledstrip.h library. We do that by typing #include and between the quotation marks, the name of the library. Including a library gives your code access to special functions that make it easier to use the LED strip, like strip.setPixel, .draw, and .clear. Next, we need to give the LED strip a name. I've named mine strip. We need to complete this LED strip function. It has 3 arguments. The first is how many pixels are on our LED strip. The second is which pin of the maker board is plugged into the green wire of the LED strip. And the third is which pin of maker board is plugged into the blue wire of the LED strip. We're also going to create a variable above the void setup function. To create a variable, you first name its type. This is an integer variable, shortened to int. That means our variable can only have values that are whole numbers, no decimals. Next, you name the variable. I'm using color because that's what this variable is going to stand in for, the color on our LED strip. Then we use the equal sign and give our variable a starting value. No code is needed in the void setup function, but we still need to create the void setup and have an opening and closing curly brace on it for this code to run correctly. Within the void loop, we're using the setPixel function. The setPixel function has 2 arguments. First, which pixel or pixels do we want to light up? We're using strip.all to tell the LED strip we want to light up all of the pixels that we have available. The second argument is a color value. In past projects, we've used a number from 0 to 299 to represent the color value. Now we're using a variable to stand in for that color value. So the first time this loop runs, color is going to equal 0 because that's the starting value we gave to color. Next, the strip.draw function sends the setPixel data to the LED strip and displays it for you. On line 15, we have color plus plus, and that plus plus adds 1 to the value of the color variable. So on the first run through the loop, color equals 0, and then the code hits line 15, color plus plus runs, and now color equals 1. A delay of 1000 milliseconds pauses the code here, so that means that each color value that's displayed on the strip is going to display for 1000 milliseconds before the code jumps down to this if statement. The if statement here has 2 parts. Between the parentheses is a condition that is checked, and between the curly braces is actions that run when the condition is true. We're using this if statement to stop the color variable from rising above 299. We know 299 is the max color we can show, so if we go above 299, we're not going to see anything on the strip. So, if the color variable is equal to 299, and remember, we check if 2 things are equal by using 2 equal signs. If that's true, that color has reached 299, then we want to set color back to 0. You notice here that when we're setting the value of a variable, we use 1 equal sign, and when we're checking the value of a variable, we use 2 equal signs. So if color reaches 299, reset it to 0, then the program reaches the end of the void loop, jumps back up to line 13, and does the setPixel function again, setting all of the pixels on the LED strip to the color determined by the value of the color variable. So if we imagine how this will run, at first we're going to set all of the pixels to a color value of 0, display that, add 1 to color, delay for 1000 milliseconds, and then check to see, is color equal to 299? It isn't, so the actions of that if statement are skipped. We reach the end of the void loop, come back up, and now set all the pixels on the LED strip to a color value of 1. Display that, add 1 to color, and wait 1000 milliseconds with a color of 1 on the LED strip. If there are 300 colors, 0 to 299, that can display on the LED strip, and we use 1000 milliseconds or 1 second to display each color, it's going to take about 5 minutes for your LED strip to make it through all the colors that it can display. You can play with this delay if you want to make that color change faster.